So let's continue on the transformations. Yesterday, we went through all the Windows functions. Okay, let me clear the cell output. So today we'll understand joins and other transformations. Okay. So for the joins, we need at minimum 2 data sets. Okay. For that, what I'll do, so yesterday we covered all transformations related to functions, which is window functions, and then group functions as well. So today what we'll do, we'll understand the joins. For the joins, we need 2 data sets. One anyway, it's employee data sets already. We have this. We have already employee data set. Then we'll use another data set as a department. Okay. So that sample data also, which you can find in my GitHub. If I go to my GitHub repository. This is my GitHub repository. This is CSV file is available. Just we can copy this as raw data. And we can create a data file. Similarly, we created employee data set, right? So similarly, we can create the MS Spark utils, fs.put, the files, and the EMP. So I'll create a file name. One and close with the triple quotes. Copy paste this data. If file already available, just to overwrite the file. Now the file is created. Let's create another data frame. So file name with the location. So now we have 2 data sets. Now we have 2 data sets. This is employee data set, where we can see the employee number and the department number. So there's 2 data sets. So the common column, if you want to join, right? So you need a common column. You need a common column. So common column here it is. We have a department number. Okay. So I'll apply directly our transformations here. One is a drop NA. If all are null, drop duplicates. Okay. Now we have 2 data sets. One is employee data set. Now we don't have a duplicates. We don't have a null records also. Now we see here, department 10, 20, 30, and 80 is available here. Then another data set is, I'll display that data frame as well. So this is having a department number, a department name, department location. So here it is a primary key, or you can say key columns, which is department number, and it is having 10, 20, 30. and 40. So if I'm looking for employees and their departments. So employees and their department, there's two tables. The common column is department number. So if you want to join a data set, you need a common column. So here we have a common column as department number. So using this department number, we can go and create a new data frame. So how to join? So before that, first I'll explain the joins in a SQL, then we'll understand in Pyspark. But how to access these two data frames in a SQL? We can create a temporary view. Okay. There are two types of views are available, temporary view and a global temporary view. Temporary view, which we can use directly within a notebook. If you want to use in another notebook or another user, then we need to go with a global temporary view. So how to create a temporary view? Data frame name. We can use a transformation called create or replace temporary views. This is an employee view. The view name which I'm giving here, this is a transformation, is a function, right? So we need to give as argument as a view name, which view name you want to create. Any view name we can specify. So I'm specifying here it as view name as employee view. Now we can use in a SQL. Same data frame, we can access in a SQL using temporary view. Okay. So and when we are writing a queries, always the left table should be a bigger table. The right table always will choose a smaller table. Okay. In these two tables, or you can say two views or two data frames. Employee is a bigger one, department is a smaller one. So which one you are looking for first? That is the first data set. Then you can use a join. To join, if you want to give alias name here, you can give alias name, table alias name, or you can say view alias name here. Another one is, so this is a giant syntax in SQL. Select start from left view, that alias name, another name, join, and another date view, or you can say table. But how it will combine the result? So there's a on class is available, on condition, the condition which we need to specify. What is the condition here? Employee table alias name is E, that is having a department number equal to department is a view that is having alias name is D, so that is having a department name. So join or inner join both are same. So it will give you the matching data from both the data sets. So 10 is available in both. You see here. 20 is available in both. 30 is available in both. This is about inner join or equi-join. So matching data from both the data sets, which we can see. If you're looking for matching data, then unmatched data. If you're looking for matching data and unmatched data, then we can go and use other types of joins. And those all are left outer, right outer, full outer. Let me write the joins here first. Join types. First one is inner join. Matching data from both the data sets. Our views, our tables, our data frames. Whatever the name you can call it as, okay? Left outer join. Matching data from both views, I can say data frames. And unmatched data from left data frame. Let's consider here. Employee is having a department number 10, 20, 30, 40. And department is having a department numbers. Here it is 80. Here it is 40. So 10, 20, 30 is common in both the data sets. But 80 is, 80 is available in left employee, not available in department right side. Similarly, 40 is available in right side, which is department, not available in employee data set. So when we are looking for inner join, you will get 10, 20, 30. So here you will get 10, 20, 30, 40, sorry, 80. Similarly, right outer join. The matching data from both the data sets, both the data frames. Unmatched data from right. Just 10, 20, 30 from both, and 40 from right side. Similar joins, similarly full outer join also. This is matching data from both data frames and unmatched data from both the data frames. Which you will get a 10, 20, 30, 80, 40. When there are additional two more types of joins available, left semi join. Left semi join means only matched data from left data. Just 10, 20, 30. Left anti-join, only unmatched data from left data frame. Just 80. So there's a lot of different types of joins. Let's understand one by one. Inner join or equijoin, matching data from both. Left outer, matching data from both, unmatched data from left side. Right outer, matching data from both, unmatched data from right side. Full outer, matching data from both, unmatched data from both. Left semi, matching data from left side. Left anti, matching data from unmatched data from left side. These are different types of joins. This is inner join. You see 10, 20, 30 from both. If I use a left outer join, left join, left outer, both are same. Left join or left outer. Outer is optional keyword here. You can use even if you are ignoring also, no issues. Okay. Now let's verify here. 10, 20, 30 from both you see here. But 80 is available in left side, not available in right side. That is called matching data from both. This is employee table, department table. Unmatched data from left side only. Okay. This is left outer join. Similarly, you can use right outer join. When we will use a right outer join, matching data from both, unmatched data from right side. So 10, 20, 30. And 40, which you can see the right side, which you don't see the left side. 40, which you can see the right side, which you don't see the left side. Similarly, full outer join. Matching data from both, unmatched data from both. So 10, 20, 30 from both, 40 from right side, 80 from left side. Which you see here. This is called full outer join. These are common types of joins which you can find in most of the databases. Similarly here also. Okay. Then additionally, we have a left semi, left antigen. Left semi means you don't see the right side, only left side, matching data 10, 20, 30. Okay. Then left anti, only unmatched data from left side, 80 from left side. These are different types of joins which we can go and use. Okay. The left anti join, unmatched data from left side, left semi join, matching data from left side. You don't see right side over here. Okay. Now, let's understand how to use the same joints in Pyspark, because we are using it two views here, right? Similarly, how to use same joints in Pyspark. This is a data frame, left data frame. The join is the transformation. So you can create a new data frame, join df. From left data frame, join. Join is a transformation. It's need a 3 arguments. You look at this syntax also. Parameters. The first parameter is other data frame, which you are looking for right side data frame. Second parameter is condition, joint condition, which you can give a string or list or a column. And the third one is, which is optional, but still you can go and give in a string, which is join type. Which join you want to give, that is, you can give in a string. Second data frame, comma, condition. We can give in a string. We can give in a expression. Expression means like this data frame is having a department number. And then equal to, in Python equal to means double equal to. Then this data frame is having department number. Slicing, we'll call it as slicing. Third argument is join type. In a string, double quotes, like inner join, left join, right join, which you can use strings. If you're not giving anything, third argument, the default will be inner join. Even if you're not giving a third argument, default will be inner join. Inner join, only matching data from both. Okay. Then if you are looking for left outer, so you can use left underscore outer or just a left join. So it will use a left outer join. Now you see matching data from both 10, 20, 30, and 80 is unmatched data from left side, which is not available in right side. That is called left outer join. Similarly, you can use a right outer join. Party is not available in left side, which is unmatched data. We are getting from right side and matching data from both. This is right outer, right underscore outer, or just right outer also you can use. full outer. Matching data from both and matching data from both. Then another one is left semi. Semi or left semi you can use. One the left data frame matching data. Left anti. Okay. Just I'll give it here if you want in a separate data frame. This is left. We include as inner join. Okay. We don't want just display the output, just want that right here. So left join. Right DF. Then right join. Full data, full join. Okay. Left to semi join. Left anti join. Can use a left outer, left join. Okay, left underscore outer, left outer also. Okay. These are the different types of joins. The join is a transformation. So we can go and use all this. Inner join, left outer, right outer, full outer, left semi, anti semi. Okay, left semi, left anti join. So then there is another join called cross join. Cross join is not directly on inside a join. You can't use like this because cross join when we will use if you don't have a common condition. Without condition means cross product. So left data frame, cross join, directly right it. That's all. Only one parameter. Okay. This is cross product. Cross product means A into B. So if you have a number of rows, 10 rows in left table, 5 rows in right table, 10 into 5, 50 rows you will get. Okay. Similarly here, 50 rows in 15 rows in left side, 4 rows in right side, you will get 60 rows. Okay. So cross join is without a joint condition. Without joint condition. Cross product will call it as cross product. A into B. Cross join is a separate transformation. Join is separate transformation. It's a 3 arguments is required. First argument is another data frame. Second argument is the condition. Remember, double equal to is equal to in Python. Python equal to means double equal to. Single equal to in Python is assignment when you are creating a variable, when you are creating a data frame, right? So here we are using equal to. This is assignment operator. This is conditional operator. So in Python, double equal to is a conditional operator, equal to is an assignment operator. When we are creating a data frame, when you are creating a variable, when you are creating array. So we'll use equal to is assignment. But in programming languages, always like this. But when it comes to query language, equal to is for conditional operator. That's why we used here a single equal to in a SQL. Here. Okay. So here we used a double equal to. If you use a single equal to, it will throw exception. You can try that also. And it will suggest also. See here. Expression cannot contain assignment. Perhaps you mean assignment means equal to. It's called expression cannot contain assignment. Equal to is assignment operator. Then here it is a conditional. Conditional operator always double equal to. Okay. This is about different types of joins. So most of the projects always will prefer and use left outer join only. Matching data from both, unmatched data from left side. Why only left side will prefer? Because left side is the driving table. Left side is the main table which we'll use always. Okay. Whenever we join any tables, left side always a bigger table, driving table or transaction table. Right side tables are smaller. That's why always will prefer left outer join, which you can see in most of the projects. Equi join or inner join, left outer join. Still, you can see other types of joins also. Okay. Still, we can go and use other types of joins. Those are left anti-join. Okay. Left semi-join, outer join, right outer join, the cross join. So this is about different types of joins. Whatever you are comfortable, there's no difference in the performance. If you're comfortable in SQL, go and use in SQL. If you're comfortable in Pyspark, go and use in Pyspark. Same SQL, you can go and create a data frame also. So create a view, again write a query, create a data frame. This is also possible. Okay. See, data frame is created. You can write a query and you can go and create a data frame. So that's the advantage of Spark.SQL. Spark.SQL, you're writing in Python, but it will allow inside as SQL queries. So that's why if you know both syntaxes, then you'll have more clarity on that. More clarity on that. So which you can, if you are comfortable, go and use. Okay. So this is about a join. So just I'll give some time. If anyone is having any questions, you can ask me now. Then we'll move on another topic. Okay. So good.
Ravi, one doubt here.
Yeah.
You are telling that while doing join, we need to see that bigger table in the left side. So,
Yes.
rows, number of rows count, we need to see the bigger size or how it is, columns.
Number of rows only, always number of rows only, a bigger table.
Okay.
The columns maybe a maximum number of columns, like less than 200 or 300. The number of rows, any rows, it may be million rows or trillion rows also possible.
Okay.
Any other questions? Yeah. Okay. Then we'll move on another topic. select expression. Select expression also is very important transformation. So on top of the data frame, so let's select EXPR. Consider if you want to select all the columns, so you can use a just a star, all the columns. But this star all the columns, right? So when it comes to all the columns, the expression always look for the expression. If you select only columns like a select, okay, then create a data frame. The name itself is the EXPR. EXPR means expression. So always will prefer for expressions. Okay, if you are selecting only columns, you don't need expression. Okay, and then if you are selecting only your columns, then you don't need to use the expression because it same thing will work for both the select also. Like if you are selecting a columns, we have a select is available, select EXPR is available. Then when we will use a EXPR. So expressions. So what I'll do, I'll add a new column. So how to add a new column? Okay, I'll use the current date as created date. You see here, directly we are trying to add a new column. Normally in data frame, if you want to add a new column, we have to use a with column. But here select expression will allow SQL kind of syntax. And so I want to add a new column, which is a total salary. Salary is one column, then NVL. So commission is another column as total salary. Why we are using NVL here? Because the commission is null is there. We are adding this plus if null is there, pass the 0. If NVL is the function, if the commission is having a null, it will pass the 0. Even we can add it here, another column. NVL. So commission is the column. If commission is null, pass the 0. Now you can see here, commission is 78 it is coming. Commission null is there. Wherever null is there, it will pass the 0. If it is null is not there, then NVL is the function. First, it will take that commission column. If it is null, pass the second value as a 0. If commission is having a not null means it is some value, then it will take that value only. So that's why here we are using NVL. If commission is having a value, then it will take that value. If commission is having a null, then it will take the 0. Why we are giving a 0? If you are not converting null to 0, what will happen? Then the null plus anything is null. You see here, 800 plus null you are getting. 2975 plus null we are getting here. That's why we are using NVL function. So this is SQL. So internal select expression will allow directly a SQL expressions. We are adding a column. Okay. Now, if you don't need all the columns, you can select a required column. So that is called maybe you're dropping other columns. Consider I don't need all the columns because I want to rename this. Consider rename as employee name. Okay. Now we'll have employee name, created date, new commission. Still, I need a sal. Sal, I'll rename. So it's renamed as salary, total salary here. So renaming can be done, removal can be done. Like if you are removing, if you're not selecting other columns, that you are removing other columns, okay? Directly. We are creating a new column. Normally we'll use a with column. So here you don't need to use a with column here. Just directly I'm using that. Okay. Even we have a high date. You want to change the data type. You can use a to date. So to date is the function high date, and we can use the expression. Okay. But everything you have to specify in a double quotes. You see, high date is properly converted. Date also, date format. These two are date formats. Created date is also date format. High date also. Now we converted. What we did, we used a to date function. Then we created a new name. So select expression as you can do whatever you do with a with column renamed, for changing data type, drop, select, even select also. So this one is going to help you. Whatever you do with the df dot with column, df dot with column renamed, df dot drop, df dot select. So multiple transformations you can combine together. That's a select expr. But all the expressions you have to do with double quotes SQL expression, because it will allow SQL syntax. It will allow SQL syntax. You can go and write a Spark.SQL. You can write directly a SQL query. That is possible. But here it is a double quotes. Every column as a double quotes. Go and specify like this. This is called select expr, which is will help you for the new beginners. If they're not good at the Pyspark, still they want to apply all the transformations like SQL, they can use a select expr. Okay, use the select expr. Okay, is that clear now? Any questions? Okay, good. So joins, select expression, and then the previous session we covered other transformations. Okay. So functions, window functions. Window function is not a transformation. Okay. The transformation is with column. With column we are going to use and create a new column with the help of function. That function is window function. The window function where we used a ranking. Okay. Those are part of with column transformation. So if you look at here, we applied a with column for changing data type to date. And if we changing data type is a type casting. Even with the column we used for adding a new column for the rank, first value, last value, lead, lag. Similarly, window functions, window with the group functions like a minimum, maximum, average, which is a running total, running averages. Okay. So those all are functions. Anything data frame dot, that is a transformation. Anything data frame dot, that is transformation. And even data frame dot also, if you are actions, those actions are displaying the data. So let me show you that. Your data frame dot count, it will display the data. Now, whenever you use a count, count is an action. So whenever you use a collect, whenever it is running a job and giving you the output, that is an action. Okay, that is an action. So data frame dot, if it is returning a data frame, then that is an action, transformation. Okay, always remember, any function returning another data frame is called transformation. Any function, any df dot function, okay? Not individual function, df dot function. Returning result set, you can say output or data is called action. And data from dot write also an action. Even data frame dot write also an action. Like if you want to save this data, then we need to use the write API. Display the data, collect we can use, show we can use. Okay, show you can display the data, count you can use, count, collect, display, show. These are running a job and giving you the output. Output means the result set. Okay. And whenever you use this with column, select expression, drop, repartition, college, these kind of transformations means functions are transformation because it is returning another data frame, returning another data frame. Okay, that's the difference which you need to identify. And let's start understand this write API. So write your data frame dot write, then the format, which format you want to write. Consider you want to format as a delta. Then you can use a mode. Mode you can use append or overwrite. Overwrite means if data already available, it will delete all data and it will create a new file. It's called overwrite. Append means even if data already available, then data already available, just insert the data, that is called append. If you're not using a mode, first time it will create a table, second time it will throw the exception. Okay. Mode is mandatory for this write API. Another one is save as table. Save means file, save as table means creating a table. Let's create a table here. Employee data. Currently, you don't see employee data table here. Let's go on right table. We're creating a delta table. Once it is available, you can refresh. It will be available. Okay. Now let's verify here. That is completed. You can find the new table. You can go and query the table. Select star from MP underscore data. If the table is created or not, the table is created. Okay. Table is created. Data also available. Now, if you run it again, what will happen? The write API, data frame dot write, then format delta, but we are not using a mode. The first time it will run. Second time, whenever you run, you will get error saying that was tabular view already exist. So choose a different name or drop a table or replace table. What do you want? So you want to create a new table, go and specify the new table, or drop the table and create it, or use the mode. Mode means where you can use overwrite. What is overwrite? Consider the table already having some records, which is 15 records are available, right? If I insert it again, it will delete all data. Then it will insert again 15 rows. So now if you go and query the table, you can find only 15 rows. because the old data is deleted. If I use append, what will happen? Old data will be there and new data will be inserted. So old 15 records and new 15 records. Again, you can find the 30 records here. Old already 15 records, then new 15 records, 30 records. If I do insert it again, then what will happen? Append is just inserting, keep inserting. Then 30 plus 15, you will have a 45 records now because 3 times it is inserted. Okay, 3 times it is 45 records. If I use overwrite, so it will delete old data. It will insert the data. Only 15 records because old data 45 records are deleted. It's inserted again. This way where we can use a mode. Then another one like a mode default. It won't be like default is error. It will throw exception. So if you want to table already available, just you don't want to insert the data, there is option called ignore. Append or overwrite we will use. Append means keep appending the data. Overwrite means delete old data and create a new records. Ignore means it will just go and ignore the data because the table already available, data already available. No insert, no delete, just called ignore. First time whenever you are creating, it will create. The next time, this is for next time. Append, ignore, these all are next time. Error means, so it will raise exception. It will raise exception. It's not displaying the message. So now it is appended. Append means old again new. Total 30 records, 15 plus 15. This is about mode. Then we have another option called merge schema. When merge schema will come into the picture. Consider this data frame. If I add another column, so I'll add a created any column. Okay. I'll import that function. Now the data frame is having extra column. The old table is having old table does not have that column. What will happen? It will raise an exception. What is exception? Because your table is having these columns, your data frame is having additionally one more column. So schema mismatch. Schema mismatch. If you have a schema mismatch, if you want to add that column, then use another option as option as a key value. Option means key means like merge schema. And the value provide that true. That's all. Key value, key and value. Value means you can give a Boolean value. Key means parameter name. So merge schema. Merge schema, what is this will do? If table and the data frame number of columns are not matching, only number of columns, not related to data. Okay. Then if those columns are extra columns in the data frame, those columns will be added in the table. Okay. Now it is not throwing error. Now the column will be added into the target table. Now you can go and find there is a column is added. That column is added only with the new data. Old data will be always a different. But what happens if any data type changes? Data type changes is not possible here. Okay, merge schema will work only for adding a new column, but not for data type changes. Consider existing column, data type got changed. Consider here it is a string. Now I'll go and change the data type as hide data only. I'm changing to date data type. Now this will have a, instead of string, that hide date will have a date data type. Now it will, if you try to write, what will happen? It will throw another exception saying that was failed to merge fields hide date and the hide date. Why it is failed to merge? Because of data type issue, because existing data type is different, new data type is different. Which line you are getting that error also you will get. So this scenario, merge schema won't work. So you have to use override schema. Override schema works only for override, not for append. You see here, same issue again. Because data type changes, what will happen? Old data will be there, right? Old data will be there means you can't change the data type because existing data is a string. You have to change the data first. Okay, so override mode only can use override schema. Okay. Now override schema worked. Now let's go and verify this hide date will be changed into ABC to date column. See here, date is changed. So whenever you want to add a new column, if any new columns from data frame and those columns are not available, those columns are not available in data frame, sorry, in table, then use merge schema option. Okay, and you can use for mode. It works for both. It works for append or overwrite mode. Then if any existing column data type changes, then and those data type changes want to apply on target table, then use overwrite schema to true and use mode as only overwrite. Okay, only overwrite mode only this will work. Append mode it won't work because append mode means the data already will be available. This is about writing a delta format, mode overwrite or append or ignore, and then option for overwrite schema, merge schema. Merge schema for adding a new columns. If you want to change the data types as well, then use override schema. So override schema works for both, for adding a new column or changing data type. Okay, but merge schema for it works for only adding a new column. So this is about write API. So tomorrow we'll continue from here. Tomorrow we'll understand the partitioning, how to create a partition table, and instead of save as table, how to save the data in a location. That options also we'll see. Okay. So with tomorrow, what we'll do, we'll understand that other options, partitioning, how to use a partition by. Similarly, how to use a save option. Now we are using a save as table, right? Similarly, how to use a save option. Okay. So I'm done from my side. So if anyone is having any questions, you can ask me now. Any questions? Okay then. So if you don't have any questions, we can wind up today. See you tomorrow. Thank you.
Thank you, Ravi.
Thank you all.